everyone, my name is Manila Sandhu. I'm from India, pursuing my Masters in Computer Science at Lakehill University, Canada. Currently, I'm a visiting research scholar at Furman University in the States. All this because of the opportunity I got from MITEC's Global Link Research Award. Enough about me. Let us come to the real question that we all are here for. How can we simplify policy making for complex systems? Today, I'm going to discuss my research on automatically validating such complex systems of health-related factors like obesity using machine learning approaches to aid policy making. To start with, we'll be beginning with the objectives of our research, and then we'll go ahead with the data collection, methodologies, and finally we'll discuss the results that we found. Coming to the objectives of our research, we use the Twitter API to collect a data set, and after collecting the data set, we pre-processed it using a script which used NLTK library, and then we lemmatized these tweets using Stanford Core NLP, and then we are aiming to fetch the map using network X, and then find the derivationally related forms of the nodes of those maps. Using these derivationally related forms, we are going to fetch the relevant tweets, and then finally we'll run the LDA model and TF-IDF weighting on those tweets, and then finally confirm our map. To start with, the data we collected was divided into three parts. First of all, obesity. For obesity, we used academic reports, which had 3 PDFs and which included 4,302 sentences, and Twitter API, which we collected 6.6 million tweets. And for political data set, we collected 14.5 million tweets. And the user map that we inputted was, for obesity, was PHSA map, which included 177 edges and 98 nodes. And for political data set, we used political map of 7 edges and 7 nodes. After processing the data set, we found out that the relevant data that we collected was, for PDF obesity, 3,447 sentences out of 4,302 sentences, and for Twitter, 1.7 million tweets out of 6 million tweets. Whereas for political data set, we fetched 1.6 million tweets out of 14 million tweets. Now, in this research, our research is divided into two parts: confirming map and extending map. For confirming map, we are using GenSim topic modeling with LDA library and scikit-learn library to arrange our themes using TF-IDF weighting. And for extending our map, we're using PySpark model using association rules with FP growth tree. So how does it start? We are pre-processing our tweets by following these 5 steps. We start with removing the URLs, mentions, hashtags, and numbers. In the step 2, we are removing the punctuations, emojis, new line, extra space, and lowercase. Finally, we contract those words which have extra length of them. For example, food is converted to food, like we properly use it. And then we are expanding acronyms as well as correcting misspelled words. After that, in the step 4, we are removing reserved words, stop words, as well as user-specified stop words. Finally, we pass our tweets through a lemmatization script to get rid of convert them into their lemma form, that is their root form. So how does our methodology start? We can see we first of all input a graph using network X. Here we are using our PHSA map or our political map. For explaining to you guys, I'm going to use this example of obesity. So we are inputting the obesity map using network X, and then finding the relevant derivationally related forms for each node. You can see for obesity, we have obesity, fleshy, obese. These terms are fetched using WordNet library of NLTK. Next, we are going to use these keywords to fetch relevant tweets. As you can see, for obesity, we have obesity, fleshy, and obese, and any tweet that has such keywords will be fetched for that key value. As you can see, obesity causes stress, so it's a part of the key value obesity. Now we're going to run our LDA model for each key value. And after running the LDA model, we are going to arrange them using the TF-IDF weighting. For our research, we used LDA multi-core model to increase the speed of the topic modeling. After that, we are arranging them using TF-IDF weighting and fetching the most accurate ones. And then we're going to map it back to the derivationally related forms of those nodes and find out if they are there, and then confirm those edges, as you can see in the diagram. Coming back to the extending map thing. For extending map, we are using FP growth model, and we're going to specify the support threshold and minimum confidence value, and after that we're going to get rid of those irrelevant rules by using a lift rule as well. And finally, I would like to share my results for the obesity map. As you can see, out of 177 nodes, 138 got confirmed, confirming my 80% of my map using the academic reports. As well as for the Twitter API, you can see it confirmed 26% of our map using Twitter data. And on our political data set, you can see that 4 out of 7 nodes are confirmed, which is a good use of political data set. As well as we also ran a sentiment analysis on the political data set, which gave us results like the following. As you can see, Kavanaugh and Democrats, the positive sentiments of those tweets was 19% and the negative was 25%, stating that the relation between Kavanaugh and Democrats was mostly perceived in a negative way. Finally, I would like to conclude on this, that given the importance of developing accurate conceptual models of such systems, the modeling process often seeks to be very comprehensive by including experts and community members. So they are generally conducted with a facilitator. The limited capacity of such facilitators limits the number and geographical diversity of participants. In addition, participants are not open to express their beliefs, example, race discrimination, because they may be perceived in a wrong way by the facilitator or the other people in the room. So in contrast, the naturally occurring exchange of perspectives through social media provides an obstructive approach to collecting beliefs on the causes and consequences of obesity. While obtaining a model where social media can inform policymakers about popular support for possible policies, the model may stand in stark contrast to an expert-based model. Identifying and reconciling these differences is an important step to integrate social computing with policymaking. Finally, I would conclude that if we are using the Twitter platform as well as the academic reports to fetch the policies, it will be a better way to find the comparison between them. For more details, you can contact me on my email ID as directed here. Also, I'm going to share the detailed presentation below for you to go through all the libraries that I'll be using. Thank you, everyone.